So hello guys, in this video we are going to discuss the solution to the problem Manhattan permutations which appeared in the Codeforces round 953 diff 2 which happened today. So in this problem we have been given a permutation. We have to choose a permutation. We have to choose a permutation P1, P2, P3 till Pn, and we have to find the value such that the total sum will be equal to modulo P1 minus 1 plus modulo P2 minus 2 plus modulo P3 minus 3 till modulo Pn minus n. So we have to find the total sum like this, and what we have to do is that we have to for each permutation the values that we will subtract will be fixed. So this 1, 2, 3, 4 till n will be fixed. So the only values that will change will be these permutation values P1, P2, P3 will only change. So what we have to do in this problem is that we have to choose a permutation such that the sum when we take the total sum like this, using that permutation that we have chosen, the total sum will be equal to the value k that they will give us. So they will give us a value k. So we have to choose a permutation p such that the total sum, after choosing the permutation p, the total sum that we get by doing this operation will be equal to k. If we are not able to form such a permutation whose entire sum will be equal to k, after taking the sum like this, we have to print in no. So this is the problem. So this is basically like you have to make some observations for this problem. The major observation that I think was so one observation that helped me in finding the other observations for this problem was that the sum that we take like this will always be a even number. So suppose if you take n as 5, n is equal to 5. What are the permutations of n is equal to 5? 1, 2, 3, 4, 5 is one permutation. You can swap 2 and 1. 2, 1, 3, 4, 5 is another permutation. You can do this. You can 1, 3, 2, 4, 5 is another permutation. Likewise 5, 4, 3, 2, 1 is another permutation. Okay, these are all the permutations. Like there will be 2 raised how many permutations will be there? For each value it will be 5 factorial, right? So we can we can set any of these 5 values here. So the first position will contain 5 possibilities, and after we will place one value over here, the second position will contain 4 possibilities. Likewise the third position will contain 3 possibilities, and so on. So the number of the ways that we can arrange for n is equal to 5 will be equal to 5 factorial, right? And even if you choose any of these permutations, the sum that you will obtain after doing this, after taking the sum like this, will always be a even number. So I think you can make the observation by trying out a few test cases. How I got the observation is that I did a brute force and generated all the permutations, and I calculated the sum for each permutation, and I checked the values, and I found that all the values were even. So I did the brute force to find some pattern or something, but I was not able to see any pattern, but I saw that all the values will be even. So that gave me the next step to the next observation. So the next observation that I made is since it will always be even, so what I'm going to do is that so this will be fixed, right? Suppose the value n is equal to 5, n is equal to 5, the 1 2, so we have to choose a permutation P such that P1 minus 1 plus P2 minus 2 plus P3 minus 3 plus P4 minus 4 plus P5 minus 5, right? So 1 2 3 4 5 here will be fixed. It is the index, right? The index in one piece indexing, the indexes in one piece indexing. So what I'm going to do is that, so initially we will have a k, so one observation that we can make is that if we so suppose initially the permutation that I chose is 1 2 3 4 5, 1 2 3 4 5, and suppose the k is equal to 6. Wait, I don't want the k to be 6. Okay, suppose the k is equal to 10. I want the k to be 10. So I want a permutation such that when we apply this when we take the sum of the permutation like this, the total sum will be equal to 10. Right. So suppose the permutation that I choose initially will be equal to 1 2 3 4 5. So I will do some operation from this such that we will get the permutation that satisfies this condition, or we will check whether we can't form this permutation or not. So what I want to do is that, so since we want the total sum of this permutation as and we are going to subtract this permutation from these values 1 2 3 4 5. These values are fixed, so these values are obtained from these values over here, the index is over here, and this is the permutation, this is the permutation P, and this is the index that we are going to subtract from. So since we want k is equal to 10, and one observation that we have to make is that the total sum now is equal to the total sum now is equal to 0, right? Because at each index the value of the index is same as the value of the permutation. So the total sum is equal to 0 right now. And if we change one value, so suppose if we change this value to some other value, then two values will get disturbed, right? So this value will get disturbed, and the position to which we are shifting this value will also get disturbed. So suppose we are swapping 1 and 3. So 3 will come over here and 1 will go over here. So 1 and 3 will get disturbed. So we know that in each operation, at least the minimum number of values that will get disturbed is 2. At least 2 values will get disturbed. So that's one observation that we have to make. It's not an observation, it's a logic that you already know. Okay, so what I did is that so if I try to swap this one with the largest value. When I try to swap this one with the okay, actually I'm not going to do that. I'm going to do that. What I'm going to do is that I'm going to take the divided by 2. I'm going to divide this k by 2. What will I get? I will get a value. If I divide k by 2, I will get k by 2 is equal to 5. Initially k is equal to 10, so k by 2 is equal to 5 right now. K by 2 is equal to 5 right now. So I will check. Okay, currently I am standing on the first index. I will check what value, if I swap what value to this first index, will I get a sum almost near to 5. So if I swap what value, if I swap to this first index, will I get a value almost near to 5. And I will tell you why I took k by 2. I will also tell you why I took k by 2. So from this observation I can we can see that if I swap 5 to here, so I swapped 5 over to here. if I swap 5 over here, it will give us, so 5 minus 1 it will be equal to 4, right? So it will be the closest value that you will get to 5. Like if you check and try to swap any other values to this first index, you will not get any value that is closest to 5 other than 4. So this is the closest value that you will get by swapping 5 to the index 1, and we had a 1 over here, right? So we will swap that 1 over to the index 5. So the total sum is equal to 8. So the total sum that we have right now is equal to 8, since the middle values are not contributing anything to the sum. Okay, now I will tell you why I took k by 2. So since I'm gonna swap two values, two difference will contribute to the sum. So this contributed a 4 to the sum, and this contributed a 4 to the sum. So I know that when I swap one index, there will be two contributions. That's why I took k by 2. So I don't want the entire k to be contributed by one value. It's not possible. So if I try to make a single value contribute to the entire k, it's not possible. We already proved that if we swap one value, another value will also get swapped, another value will also get changed. So two values is the minimum number of values that will contribute. So that's why I took 2. So since divide by 2, since we know that not only this value will contribute, so this value also will contribute. So if I didn't take divide by 2, so and I took 5, and the entire value was k is equal to 10. So it's not like it's not obvious in this test case, but for other test cases it's obvious. So that's why it's necessary to divide by 2. So we got the sum as 8. So what is the remaining sum that we want to that we need? So the remaining sum that we need is, so the total sum that we want is 10. The remaining so the sum till right now is 8. So the remaining sum that we want to get is 2. So I will do the same operation. I will divide by 2. And I will get 2 by 2 is equal to 1. So I will go to the next index. So initially I was standing on the first index, and now I will go to the second index. Now we will see by swapping what value to the second index will I get, will I get a difference close to 1. So I see that if I swap 3 to here, 3 to over here, 3 to the index 2, so I swap 3 to over here, I will get the difference, the absolute difference as 1, right? So we got a value closely related to the sum that we wanted, and the 2 that was over here will go to the index 3, because that's where we swapped the 3 from, and this will also contribute 1. So the total sum will now will be equal to 10. So 4 plus 1 plus 1 plus 4 is equal to 10. So and the final permutation that we will get is 5, 3, 2, 4, 1. So the final permutation is 5, 3, 2, 4, 1. So this is actually how you solve the problem. So you will iterate through the index, and you will do these operations one by one. So I will give you another test case as well. I will give you another test case, and we will perform operations on that. We'll give you, what test case should I give you? I will give you a similar test case, but it will help you to understand the problem much better. 5, 2. So the test case is n is equal to 5 and k is equal to 2. So we want a permutation such that the difference of the values total sum of the difference of the values is equal to 2. So suppose the permutation that we choose initially is 1, 2, 3, 4, 5, and the difference that and the indexes are 1, 2, 3, 4, 5. So the permutation is equal to 1, 2, 3, 4, 5, and the indexes are 1, 2, 3, 4, 5. Indices. Okay, the spelling is so correct. Indices. Right. Okay. So we want the total sum as k is equal to 2. Now I will divide this k by 2. The k by 2. So I will get 1. So I need to swap some value to the first index such that I will get a value closely near to 1. So what value can I swap over here? So I can bring 2 over here. And I will swap the one that was already over here to the position 2. So it became 2, 1, 2, 1, 2, 1. So this contributed 1, this contributed 1. The total sum is equal to 2 right now. So this is how we do the problem, and I will show you the implementation right now. So this is the code to the problem. So I am inputting the data over here. So I am like initializing the initial permutation. So I told you the initial permutation will be 1, 2, 3 till n that I'm gonna choose, and I am also adding the values from 1 till n inside a set, inside a set. Okay, inside a set. So why am I doing this? So I told you, right? So I will tell you why I'm using this set. So in this remain variable, I am taking k minus sum divided by 2. So this is the value, the remaining value that we need to fulfill. So we have the sum, we have a sum till now, and to get to make the sum equal to k, we have this much remaining, and for each value we need to find a value closely near to this remain variable. So I explained in the explanation part, right? So that's what I am taking over here, and I am using the set to find a value that is closely near to this remain value. So when I was explaining the implementation, I took the value on my own, like I didn't do use any data structure. So to find the closest value to remain, I am using the set data structure over here, and I am swapping the two values. So in the explanation also I explained, right? We will swap the to the ith index. We will swap the value the value that is closely near to the remain value. Also, we will uh, swap the current value that we have to the position of the value that we swapped this value from. So we got this value from the index val minus 1, right? So we will swap to that index the current value that we are standing on, and we will erase val from the set, and we got we will add to the sum 2 into val minus I plus 1. Why am I doing 2 into I already told you in explanation, right? So since two indexes are contributing the same value, I am multiplying it by 2, and if we get the sum as k, we will break, and we will check after the for loop whether the sum became k. If it became k, we can print s, because there is a permutation such that the total sum will be equal to k, and we will print that permutation. Otherwise, we will print output no. And I will once again explain the set part. So this set is used to find the value that is closely near to this value. Yeah, that's basically it. So that's basically the problem and the solution. So if you understood the solution, kindly like or subscribe. And if you haven't understood the problem, like if you face any difficulty in understanding the problem, or if you have any difficulty with my explanation, please comment down that as well. Thank you.